Okay, so welcome to week 2, part 2. We're going to pick up where we left off yesterday. We have base data types, low-level data types in Python: int, float, stir, bool, the special value none. And we're going to look now at conversions back and forth among these low-level data types. A particular kind of conversion that's important to us is converting from strings to numbers and converting from numbers and booleans back to strings. Very often when we read data from a user or from a file, it comes in the form of character strings, and we have to convert that data in order to do computations into ints or floats, or in some cases bools. We then do our computations, and of course we have to convert back into stirs for the user to be able to read results. Just about anything can be converted into a stir through the use of the stir conversion function. If I say stir of the special value none, all the stir function does is to create a stir containing none in quotes. If I convert a float into a stir, then by default, if that value will fit, it's converted into a so-called fixed point notation without an exponent, and quotes are put around it. If the number is too large or too small in magnitude, then the exponent will be included. So for example, if I had a value, all right, so here I've got a value 12.354 times 10 to the 8th power, and that can fit fine into a fixed point notation with no exponent. But if I had 1.23 e to the let's say 100th power, then that's much too large to be reasonably displayed in fixed point format, so the exponent is included in that case. I've got my actually, I think I did not create this thing yesterday. I just went directly to the keys iterable. So let me create. Okay, let's remember N to E is our dictionary of names to email addresses, and N to E dot keys is an iterable over those keys. If I convert that iterable into a string, it's not really very informative. I simply get the same value that's displayed as the representation of the keys, but with quotes thrown around it. All right, so it is possible to convert anything at all into a stir, but sometimes that conversion is, may not be that useful for a user to read. All right, now converting to int in the case of floating point values will chop off the fraction part, and this is true both for positive numbers and negative numbers. That is, if I say int of 4.567, I'm going to get the integer part of this. It's not rounded. The fraction is truncated, and so what I get from int of 4.567 is just 4. And likewise, this is true for negative values. The fraction is truncated towards 0. Notice that this is very different from the floor division. If I say minus 4.567 floor divided by 1, let's say, then that's going to be truncated toward negative infinity to give me a floating point minus 5.0, whereas the direct conversion to int just chops the fraction off. You can convert a string to an int, assuming that the string does represent an integer value. If I try to convert some nonsense into an int, I get a complaint. I can also convert Booleans to integers, and it turns out that true converts to the value 1, whereas false converts to the value 0. Alrighty. Converting to float always works for integers, unless the integers are too large. If I convert the integer 5 to a float, that works fine. And if I convert the string 5.432 to a float, that works fine. But just like with the int conversion, if the string is nonsense, then I get an error, I get yelled at. And likewise, if I try to convert, recall that I can compute 100 to the 100th power just fine. But if I try to convert, well, actually, was that? So that's 10 to the 1000th power. That might actually fit. Let me do something that definitely won't. Let's do 1000 to the 1000th power. All right, well, not multiplication. We want exponentiation. There we go. Okay, that definitely won't fit. And in a float, and so if I try to convert that value to a float, I'm going to get an overflow error. Okay. Now, as far as Boolean values are concerned, Boolean conversions, it turns out that any numerical form of 0 converts to false. Also, an empty string converts to false. So if I say bool of 0, that's false. That's an integer converted to bool. If I say bool of 0.0, that's a float 0 converted to bool. And if I say bool of an empty string, all right, that's 2 single quotes side by side, that is false. But pretty much anything else is converted to true. So bool of 0.01, many zeros, converts to true. Bool of 1234 converts to true. Bool of a string containing a space. All right, it doesn't look like that string ought to be considered important, but since that string does contain a character, it converts to true. And of course, any other string containing any characters also converts to true. Okay, so that takes care of the conversions back and forth among the low-level data types in Python.
Okay, so now we know about the built-in collection types that Python provides. We have individual scalar values, int, float, bool, stir, and the special value none. And we have collection types. We have list, tuple, set, and dictionary, dict. Now we're going to take a look at one mechanism for obtaining some information that we can store into and manipulate using collections. This is a web scraping module called Beautiful Soup. Okay, so what we're going to do to scrape data from a website, that is to extract out the strings and numbers that are of interest to us from some website, is we're going to open a connection to the website. Then we're going to download the web page source. The source on a web page is text that you can look at, and often the text is what's called HTML, hypertext markup language notation. Modern websites often have more complex coding than just straight HTML. Beautiful Soup is very beneficial, very useful, very easy once you get used to for dealing with HTML. So that's what we're going to take a look at first. You may discover, and part of the reason that we're looking at this fairly early in the course is that you're going to need to do web scraping as part of your group project. And also, it's something that you need to know for, real jobs in real life. All right, so we're going to take a look at Beautiful Soup here. You may end up having to look at a couple of other tools called Selenium or Scrapy that allow you to scrape more advanced web pages. In any case, HTML is a hierarchical notation in which a web page is represented as a hierarchy of nested tags. The opening angle bracket, the less than sign, followed by some tag name, and then some optional additional information, and a closing greater than sign. Between that opening tag and a closing tag, which consists of, again, a less than sign and a slash in front of the tag and a greater than sign, there can be some arbitrary amount of information describing just plain paragraphs of text or images to be displayed or menus or push buttons or various other kinds of things. Okay, so we're going to open a connection to the website, download the HTML code, convert the HTML code into a Beautiful Soup object, which is more convenient to interact with than just plain old HTML text. And we're then going to be able to extract the information of interest to us from that Beautiful Soup object. All right, now I have an example program here called bsoup1. Whoops. Not a very not a very imaginative name. Okay, so this is our bsoup1 code. And what we're going to do with this is to download information about the so-called U.S. Treasury yield curve, in our case, from the year 2019. And in your homework, you'll do this for a different year, and you'll carry the process further than what we're doing here. So let me show you this code live. Let me pull it up. All right, so here is my live copy of this code in the bsoup1.py file. And I'm using idle, but you'll probably prefer to use Spider or PyCharm as something more powerful than just plain vanilla idle. Okay, in order to open a website, we need this function called URL open. And what we're going to do is to import that function from this module urllib.request. Okay, this is a module of facilities for interacting with websites, and all we care about is this one function URL open. We are going to open this URL, which gives us the table of information about the Treasury yield curve for 2019. Now, how do I know that? Where did I get this from? Well, let me just pull up a regular browser. Here we go. And I'm going to do a Google search for U.S. Treasury yield curve. And daily Treasury, I want Treasury yield curve. There we go. And what I actually want, this appears to be historical data. I want live data. Let me go to data. Daily Treasury par yield curve rates. Okay, that's what I want. I want, if you're not familiar with what the yield curve is the thing that determines what you pay for your mortgage, what you pay on your credit cards, what you pay for auto loans, what you pay for student loans, if you have the bad luck of having those. And yield curves are produced on a daily basis. Okay, daily Treasury par yield curve. This is for 2022, and let's look at the most recent day. Okay, so when I'm recording this, the most recent day that we have information for is for last Friday, March 18th. And what we can see here, I guess I went past the column headers. What we have here are interest rates for very short-term investments, 1 month, 2 month, 3 month, and so on, all the way out to 30-year Treasury bonds. All right, so we've got 1 month, 2 month, 3 month, 6 month, 1 year, 2 year, 3 year, 5 year, 7 year, 10 year, 20 year, 30 year. It's typically the 10-year rate that affects things like mortgage rates, and shorter rates like the 5-year that would affect your auto loans and stuff like that. In any case, if we go down to March 18th, we see that the interest rate for a 1 month investment in a Treasury bond or Treasury bill or Treasury note, whichever. I forget the maturities that those terms apply to, but some of these are called bills, some of these are called notes, some of these are called bonds. They're all bonds. They're all the same. They're just the terms are different. Okay, so we have a 0.19% rate for a 1 month bill. And that may seem incredibly low, but in fact, if we go back to, earlier in the year, before inflation became, widely understood to be fairly high, you can see that we've got much lower rates. Like here, we've got a 0.02% rate for a 1 month investment in February 15th, so just a little over a month ago. And in fact, if we go back to last year, 2021, in 2021, the Federal Reserve was still very concerned about the overall health of the economy because of COVID-19, and so the interest rates were even lower. So we see these. Here we go, 0.01. Which is the lowest interest rate you can have, really, since the well, I guess you could go down to 0.005 or something like that, but the interest rates back then were just tiny. And notice that we had like a 1.66% rate for 30 years. For 10 years, we've got this 0.93% rate at the beginning of 2021. So this is why mortgage rates were so incredibly low, because of these because of this yield curve. All right, well, so I've been yammering away here. Let's go back to 2019, which is the year that we're looking at in this example code. All right, so here we have higher interest rates. In fact, the yield curve on the first trading day of the year here was actually fairly flat. The 1 month rate was 2.4%, and the 30-year rate was 2.97%. So that's a relatively flat curve, and continuing on for the entire year. Not much change during 2019. Looks like short-term rates actually went down as the year wore on, and long-term rates stayed. They went down as well, but not quite as much. All right. The place I got this URL from, and I guess I'm not sure you can see it in my video, so let me pull this down a bit, is right here. All right. So once I have identified a web page that contains information that I'm interested in, I can just copy and paste that URL into my Python code. So that's where I got that URL from. Okay. Let me pull my code back up. So here's the code, and I just copied and pasted in that URL. Now, the URL is very long. And so here, I've used a nice feature of Python, which is that if you have a string, a str, in quotes, and you immediately follow that by another str, in quotes, and the reason that we can do this on separate lines is because of our parentheses here, okay? Remember that when you type an opening parenthesis, Python will allow you to continue typing more lines until eventually you type the matching closing parenthesis. So when you have a string followed by another string, Python just automatically concatenates those two things together for you. So let me demonstrate that. Here's my my shell prompt. If I say quote hello, close quote, and then quote world, close quote, that's actually legal syntax, and Python just appends the two things together. So it's literally as though I had said hello world as a single str. All right. In fact, I can do silly things like H, E, L, L, O, and these 5 one-character strs are going to automatically be concatenated together into a single 5-character str. Okay, so that's a convenient way of dealing with a long line of, or a long string that won't fit neatly into our window. Now, URL open goes out and attempts to access that web page. We've shown that the web page does exist, so the URL open will succeed, and we will get back a value that we can use for accessing that web page. To create our beautiful soup object, beautiful soup here, okay, I'll highlight it on the, highlight it over on the PowerPoint. Beautiful soup is a conversion or construction function, just like we can use list, the list function to convert something to a list, or the set function to convert some iterable into a set of values. Here, I'm giving 2 arguments. The first of these is a read function call, which will obtain the source code, the source text of that HTML document. The second argument is a specifier for formatting, telling Beautiful Soup how to interpret what has been downloaded. There are various different formats that you can use, and I've just picked LXML. I'm going to confess right here that I don't pretend to fully understand what these various different format specifications mean. LXML works in my experience for most HTML documents, so I just go ahead and use LXML. Okay, now, if we're able to convert this HTML document into a Beautiful Soup object, the Beautiful Soup conversion function will return a value, and I've set up this BSYC variable to refer to that value. BSYC is short for beautiful soup yield curve. All right, so that's my beautiful soup yield curve object. I want to look at that text using a text editor. So before I start trying to process this HTML document, I have to know what the HTML document contains. And so I'm going to create a text file using the open function. I'm using WT to specify that I want to write text into this new file that I'm creating. And I'm going to use fout as the variable name for referring to that file that I've opened for writing. I will use the stir conversion function to convert my beautiful soup object into a stir, and then write that stir, that string, out to the file and close the file. All right, so that's sort of the first section of my code. The code continues on from there, but let me, in my overall program, I'm going to put in an exit function call to cause the program to exit at that point without continuing going any further. Let me run the program up to this point by, I can press F5 in idle, or you can choose run. F5 and... All right, now I'm getting this message. This is a consequence of my exit function call. Your program is still running. Do you want to kill it? I'm actually not going to kill it. I'm going to let it continue running, so I'll click cancel here. And that way I can actually have access to the variables, BSYC, for example, that I've created in the code so far. If I display BSYC, I'm probably going to get a tremendous amount of output. It'll probably tell me, yeah, okay, so I have almost 15,000 squeezed text lines. I'm not going to try to display that in idle, but I do now have this BSYC temp.txt file that I can look at with a text editor. All right, so you could use the editor of your choice to examine that text editor. For me, the editor I like to use is an editor called VI. I have a Unix style or Linux style terminal application installed on my Windows machine because I'm an old Unix guy going back 40 years, and so I'm going to use VI to look at BSYC_temp. You can use, as I said, any text editor that you like. And here we go. So here is the very beginning of this HTML file. An HTML document starts out with this special header tag, doc type HTML. And then, just so that you won't be confused about where this came from, we have this big comment, actually, saying that this information is from the U.S. Treasury, which is fine. I mean, government data from government websites is freely available. There's no, I'm not violating any kind of copyright or anything doing this. Well, in my actual web page showing the Treasury yield curve data, let me pull that back up again. Here we go. So here is my yield curve table for each trading day of the year, and for all of these different terms, 1 month, 2 month, 3 month, up to 20 year, 30 year. And that's the information that I want. That's the information that I want to get because I would like to do some analysis on this yield curve information. I would like to be able to see whether the yield curve is rising or falling over time, whether the yield curve as flattening or steepening as the year progresses. I do want to say, I want to emphasize before we continue on here that the yield curve is only shown or only recorded on so-called trading days. So weekend days and holidays don't have yield curves associated with them. Consequently, when we look at 2019, and if you look at any year, you're not going to see the date 01/01 2019 because January 1st is New Year's Day, and that's a holiday. So banks, brokerages, etc., are not open, and therefore there is no yield curve reported for that day. So apparently, January 2nd of 2019 must have been a Wednesday because we have January 2nd, January 3rd, January 4th, and then we have a 2-day skip here. January 7, 8, 9, 10, and 11 are what we have next. All right, so we don't have any information for the Saturday, January 5th, or for the Sunday, January 6th. And then we have 5 days of information again, 7, 8, 9, 10, 11. And then we have another 2-day skip, so Saturday the 12th, Sunday the 13th, we don't have any data for. And then 14, 15, 16, 17, 18, okay? And so forth. So when you go through this table, you'll discover that depending on the year, there are typically either 250 or 251, most commonly 251, trading days during the year due to weekend days and holidays. All right, so we know that there are 365 days in the year, but it turns out that about 114 of those are weekend days and holidays. Now that makes sense. We got 52 weeks, so that's 104 weekend days, and we've got approximately one holiday each month. Okay, so that makes sense. We've got a total here of about 251, maybe 250 trading days. Okay. All right. So let me go back to my file. Now, what I'm hoping is that this string here, this string of text, 01/02/2019. I'm hoping that string of text does appear in my file describing this information, and I'm also hoping that it only appears one time, because if it appears, that means that I have successfully scraped this table into my file. If it only appears once, that means that I have found where that information is. All right, I don't have to worry about distinguishing between one place where January 2nd appears and another different place where January 2nd appears. So let's go back to my file. All right, and I'm going to search for, and in VI I search for something by saying /, and I'm going to search for January. Now here's an awkward piece of VI trivia that you don't need to care about. But notice that I use / in order to do a forward search. There are slashes in the dates that I'm looking for. And so what I'm going to say is January and then dot, which matches any character, 02 dot and 2019. These dots here are what are called regular expression characters, and we will investigate regular expressions thoroughly a little bit later in the course. Dot matches any single character, so dot will certainly match a /, and I have found a match. All right, so I've got here a match, 01 followed by a character, 02 followed by a character, 2019, and fortunately for me, those characters that are matching the dot are the / characters. I can conclude my search by hitting the Enter key, and the VI editor conveniently highlights the match for me. All right, so I have found one match. Let me search for another match, which I can do by just typing / and hitting Enter. VI, you don't need to remember this, but VI remembers the last thing that you searched for. So if you just type / and hit Enter, you'll continue searching for the same thing again. And search hit bottom, continuing at top. And I came back around. I did what's called wrapping around. And it came back to the very same string that I found before. So this is excellent. This means that I have found the string 01/02/2019 that appears in the yield curve table, and there's only one occurrence of that. So let me do some poking around here. Now this string is in a line that starts with this TD tag. Okay, the line is long and it wraps around on my screen, but if I go back to the beginning of the line, which I've done here, what I see is this TD tag. Well, I'm not exactly sure what TD might mean. Well, I actually know, but we'll pretend that I don't. So let me pull up Google again, and I'm going to search for HTML TD, and a simple HTML table with 2 rows and 4 cells. The TD tag defines a standard data cell in an HTML table. Well, that's very encouraging. My information on the website is organized as a table, and TD defines a data cell in an HTML table. Cool. So I have found one cell of data in a table. Well, let me go back and see if I can find the beginning of the table. So I'm going to go back. I'm going to search forward for table. Okay, now you can see from the highlighting that I've got the string table appears a whole bunch of times. So I guess I need to be a little more careful. I need to look for less than symbol table. Here's one. All right, so I found one. Table, views table, columns equals 20. Let me search for that again. Oh, this is really excellent. So I only have one table in this whole document. So TD is table data, and I only have one table. Excellent. So let me start trying to extract this table, and then I'm going to extract the information within the table. Now, in this table, notice that the table starts with T-head. We can use Google to figure out what T-head means. It's the header for the table. If we look back at the actual table, the header is this line. All right, so that's the header. I know this in advance. It did take me a little while to figure that out the first time I did this. All right, so that's the table header. And then the TR is a table row. And within each row, I have a table heading cell. So TH is a table heading cell in the way that TD is a table data cell. All right, so in my table header, I have table headings, and notice that the first table heading is date. And that, indeed, okay, that matches what I see on my screen. I see date as the first table heading. Cool, so I'm making progress here. Let's continue on with our code. Okay. Here, as I said, was the table data entry for January 2nd of 2019. And we used Google to figure out that TD is table data, a cell in the table. And then I searched backward. I searched to see where the table started, and I was lucky to discover that there was only one table in here, so I don't have to be uncertain about, whether there are multiple tables in here that I have to distinguish between. So let us get a list of all the tables. And we do that by invoking this findAll function on our beautiful soup object. Okay, so let me pull my code back to the fore. I'm going to eliminate this exit function call. BSYC is my beautiful soup yield curve object, and the findAll function with some string as an argument gets me back a list of all of the tagged segments within the HTML document, within the beautiful soup yield curve object, where the tag is table. Now, we know from looking at the file in our editor that there is only one table, but let's use this print function to confirm that the table list we get back from findAll only has a single element in it. And then we can obtain just that one table by asking for table list sub 0. Now, a table in HTML consists of some number of rows, and each of those rows has some number of columns. For the header row, the columns are THs, table headers. For the data rows, the columns are TDs, table data. All right, so let me get a list of all the rows. Okay, so we're going to get a list of all the tables. We know there's only one. We're going to get that one table, and then we're going to find all the rows in that one table, and we're going to display how many rows there are. And at this point, I'm going to put my exit 0 back in. So I want to run my program up to that point. I want to find out how many tables there are, and then I want to find out how many rows there are within the table. And I'm going to click cancel. Okay, so there are 1 tables. We knew that from examining the HTML with our editor. And there are 251 rows. All right. Now that means, because the header counts as a row, that we have 1 header row and we have 250 data rows. So continuing on in our program, we know that row sub 0 is the header row, and in fact, I can say print rows sub 0. Okay, and the output is long. Whoops. Okay, so I said print rows sub 0, and this is a table row, and the table row contains table headers. All right, so table header values. The first one is date. The second one is 20 year. The third one, whoops, change the size of my window. It's not what I wanted. The third one is 30 year. And then continuing on down, I eventually see, okay, I have, here are the column names that actually appear in the table. 1 month, 2 months, 3 months, 6 months, 1 year, 2 year. All right, so that is my header row. And, whoops, sorry. Notice that the header cell description is very long-winded. So how in the world do we pluck out just the actual text part contained within that table header construct? Well, it turns out that in the case of something like a table header or table data, the part that you're interested in is what's called the contents of that table header. So let me demonstrate this interactively in my code. Okay, I need to drag down to my prompt again. All right, so we did a print of rows sub 0. Now, so rows sub 0 dot find all of the table header cells. This is going to give me back a list iterable. Let me okay, so headers is a list. Headers, oh, it's called a result set, but it's an iterable like a list, so we can find out, for example, how many items there are in headers. Well, that's encouraging. 20. We saw earlier, I didn't point it out very strongly, but the table has 20 columns in it. And we can also use a loop to step through the headers. And let's display as a string each one of these header cell values. All right, so each header cell, as I said, is this long mess. We only want the contents within here, and that's what we can get by asking for the contents of each of the header cells. Okay, so instead of displaying, as we loop through the headers, instead of displaying the entire header, let's display the contents of each of the headers, and poof, look at that. All right, so when we ask for the contents, let me scroll up here. When we ask for the contents, we get date as the contents of the first header cell, and then we get 1 month, 2 months, 3 months. Now we're also getting these other things here: 20-year, 30-year, extrapolation factor, 8 weeks, bank discount. I'm not exactly sure, frankly, what all of these mean. If we take a look at the actual website, let me pull the actual website back up. These are not these are not columns that we can see in the table. Okay, the columns that we see in the table are date, 1 month, 2 month, 3 month, 6 month, blah blah blah. So only let's see, is it 14? Okay, date is 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 13 total columns in the table. Or actually, I should say 13 visible columns in the table of information that we want. That means 7 of these columns are not information that we care about. So let me flip back to my code here. And sure enough, so 1, 2, 3, 4, 5, 6, 7. These are the 7 columns that we just don't care about. So we care about the first column, and we care about the last 12 columns, but we don't care about those other 7 columns in there. Okay, let's continue on. So we've displayed now the contents of the 20 columns from the header, and the remaining rows, remember that rows is all of the rows in the entire table. Rows sub 0 is the header row. That means rows sub 1 through the end are all of the data rows, and I can use find all of TD in order to get the table data from the data rows. All right, so rows, recall, had 251 lines in it. Rows sub 0 is the header row. I'll just display the whole thing here. All right, so it's the header row. Now, rows sub 1, therefore, is the first data row, and it's long. Notice that it has these TD fields, these TD data cells, and these contents of these cells are in fact the interest rates. So let's take a look at this. So for the first data row, the last interest rate should be 2.97. Wow, pardon me. The last interest rate should be 2.97, preceded by 2.83, 2.66. Let's take a look back at our actual table. 2.97, 2.83, 2.66. Yes, indeed. Good. So we have found the data cells containing that information, and we can therefore use the same kind of for loop for each row in, well, for each row in rows sub 1 colon. That is from row sub 1 to the end. And then the current data row contains table data cells. So let's just print as a string the row data. And rather than printing it for every single row, I'm going to just ask for a slice of just one row. All right? So there, the output is long. But here we got the table data elements. Okay, so we've got the first table data element, which actually contains the date string. Then we've got the second data table element, which is NA. Now remember, we're not interested in these subsequent 7. So it's only after we get past 1, 2, 3, 4, 5, 6, 7 of these NAs that we start getting to the interest rates, 2.4, 2.4, 2.42. Does that work? Let's take a look. 2.4, 2.4, 2.42. Excellent. So that's what we want. But we only want the contents. All right, so let's, for row in rows, 1:2, let's just take a slice of one row. Row data gets row.find all of table data, print row data dot contents. Actually, okay, so row data is a list. Row data is a list, and I'm going to need to say for D in row data print d.contents. Okay, so I'm going to actually just do the first row, row sub 1. I'm going to get a list of all of the RD, all of the TD data items, and within that list of data items, I want to see the contents. So let's see what we get there, and okay, that looks good. Well, it's a little hard for me to scroll back, but that looks good. So we've got the first table data piece has the date and the time. Now, this is a little awkward to deal with because it in turn is in a nested HTML segment with a time tag. All right, so I got a little more than I bargained for by asking for the contents of that first thing. I'm going to need to ask for the contents of. I'm going to need to ask for the contents of the sub-zero table data cell. Then I've got 7 NAs that I don't care about. I'll just ignore those. And then I have my actual interest rate values, 2.4, 2.4, 2.42, 2.51, 2.4, 2.4, 2.42, 2.51. Outstanding. So now I have the actual data that I want. All right. Now the one sort of annoying thing about this data that we have is that each of these things is a list containing a string. So we need to figure out, well, how do I pluck out this string representation of this interest rate and append, because that's just one cell. This is just one cell in my row in my table. And I want to append another cell from the row in the same table and another row or another cell from that row in the same table. So I need to append together a bunch of the contents of these lists. I also need to pluck out just the date part of the time tag in the first table data. So we'll do this entire loop as shown on slide 39 here. For row in rows sub, I'm just going to do the first one again, 1:2. The data cell is, or a list of all the data cells is obtained from find all of TD within that row. And we know that row data sub 0 dot contents is this HTML tagged thing. All right. So what I want to do from the contents there is ask for just the Sub-Zero item of the list. Okay, notice that this is a list containing a time tag thing followed by a new line character. So I just want this time tagged piece, which is the Sub-Zero piece of that list. And then I want the contents of that Sub-Zero piece. So row subdata Sub-Zero is the first data cell. Dot contents is a list of all the contents. Dot contents Sub-Zero is the part that has the time tag, and I want the contents of that. So let me just print that. And we'll see that now I have, that's the actual date. There we go. So that's the date for that first row. All right. And completing this, adding in the rest of the cells. In addition to printing that first cell, I'm going to say for D in row data. Now, actually, in the code here, I'm saying 1:, meaning from cell Sub-1 to the end, print the contents. Okay, so there we go. So now my output has 20 individual data cell contents. We've got the date, which is in the first column. Then we've got 7 columns that we don't care about. And then we've got these interest rates. But I just realized that there's no reason I can't skip over those 7 values that we don't want. Let me copy and paste this code. And instead of going from 1 to the end, well, I want to skip 7, so let me just say from 8 to the end. All right, now we're going to get just exactly what we want without that extra stuff. Poof! 13 cells. All right, we've got a date and we've got 12 interest rate cells. And if I want to append these things together, okay, let me see. I've got line. Let me make line be an empty list. So I can say line.append that date. Now the date is row data Sub-Zero dot contents Sub-Zero dot contents. So I've got that list in there. And to that, I can say line Sub-Zero. Okay, that's just that list containing the date. If I say line Sub-Zero dot append row data Sub-8 dot contents, okay, row data Sub-8, row data Sub-8 is going to be this. So row data sub 8 dot contents is going to be that thing. Whoops. Okay, now I've made a mistake here. I wanted to append this value into that list following the date value. So let me try that again. So I'm going to start with an empty line. Start over with an empty line. I'm going to append the date. There. Wait a minute. What's going on here? Okay, line gets an empty list. Line is an empty list. Row data sub 0 dot contents sub 0 dot contents. Oh! Oh, I'm such an idiot. I accidentally... All right, so I modified the list line sub 0 by appending another list to the end of the list line sub 0. So I want to say, I better just try again. Let me copy and paste all of this code from my slide. Whoops. Oh, I know, because I highlighted it wouldn't let me copy. Let me turn off my highlighting. I need to turn off my highlighting. Now I can copy and paste. All right, so I can copy and paste. Oh, the indentation's all messed up. Let me Control C. Sorry, this is, well, this is real life, right? I mean, it's just doing the best we can here, so. Interesting. Okay, I have messed up the cell that contains the date string. I am going to drop back and punt and rerun the entire program so that we get exactly what we want. I'm going to move my exit. I'm going to remove my exit entirely. I'm going to make this modification we talked about so that we're going to go through the data elements starting from the sub 8 element instead of from the sub 1 element. I'm going to only look at the first data row. Let me run it. All right, and so there we go. Here is the first data row. And so row data is all of the data, all of the table data cells in that first row. Row data sub 1 row data sub 0 dot contents sub 0 dot contents is the date. Let me create my yield curve table. And I'll have that be an empty list. Then I'm going to say YC line is an empty list. And into YC line, instead of appending this list, let me append the contents of that list. So, or let me append the string from that list. So I'm going to append row data sub 0 contents sub 0 dot contents. That is a list. And I just want the sub-0 item from that list. So here is YC line. Good. Now, from row data sub 1 dot contents, oh, okay. Not row. Wow, I could not figure out what was wrong. Row data sub 1 dot contents. We don't want that one. We want row data sub 8 dot contents. There we go. That's our first interest rate value. So into YC line, I'm going to append row data sub 8 dot contents. And because contents is a list, I want the sub-0 item from the list. And now YC line contains the date and the first interest rate. And so now we're going to say for K in range starting from 9 up to, but not including 20. Let's remind ourselves what this does. We're going to say just print K. All right. For K in range 9 through 20, print row data sub K dot contents. All right, there are all the subsequent interest rate strings. So for K in range from 9 up to but not including 20, print row data sub K dot contents sub 0. Each of these is just going to be a string. Yay! And those are what I want to append for K into my YC line. Correct? YC line. YC line is my list. So I'm going to say for K in range 9 to 20. YC line dot append. And I'll just copy and paste what I did up there. Into YC line, I'm going to append row data sub K dot contents sub 0. And poof, YC line now contains, well, let's confirm that the length of YC line is 13. All right, the length of YC line is 13. And I have yield curve table up here. A little higher. Yield curve table is a list. and I want to say yield curve table dot append YC line, and let me make a copy of YC line. So now yield curve table is a list containing one list, which is the first data row. Okay. All right. Well, I think that should give you a reasonable amount of hints about how to approach dealing with the data that you've sucked down from a website. There are more steps to follow. We need, for example, if we're going to do arithmetic operations or statistical analysis or plotting or whatever of these interest rates, we're going to need to convert this string into a float, and we're going to need to convert this string into a float, and so on. And that just means using the float conversion function on each one of these values. Okay, so there we are. It was a bit of hackery, but hopefully that helps you get started. Now, Beautiful Soup is big, messy, challenging. Often I recommend that you carefully learn and memorize the facilities provided by different data types. So we've talked about symbolic and named operations that you can do with lists and with tuples and with sets and with dicts, and you should learn and memorize how all of those things work. Beautiful Soup is an exception. Beautiful Soup is big and complicated and messy and hard to remember, and so and scraping from websites is something that you'll have to do periodically, but not like every single day. So you're not going to use Beautiful Soup enough to become an expert. You are going to have to, look up the Beautiful Soup documentation online, try various experiments to see how to use it, find all and contents are critical tools to know for locating certain tagged items and for plucking the contents out of those tagged items. All right, take care.